In this video, we're going to learn a little bit about rational exponents. But if we're going to learn about rational exponents, we need to know what rational exponents are. Remember, the word rational is just a fancy way to say fraction. So what we're really going to talk about are exponents that are fractions. So here's an example of an expression that contains a rational exponent. 4 raised to the 1/2 power. Well, I know what that 1/2 is. That's an exponent. And the exponent tells us how many times to multiply the base times itself. But how do I multiply 4 times itself 1/2 time? Well, that's what we're going to learn how to do in this video. Before we get started, one of the first things that we need to know is that all of the laws of exponents apply even when my exponents are fractions. So just because we have fractional exponents doesn't mean that our exponent laws just fall apart or do not apply anymore. Of course, they still apply, even though we're going to be working with exponents that are fractions. Now that we know that, let's see if we can discover what it means for an expression to have a fractional exponent. Let's look at this expression. Square root of 10 squared. If we start with the number 10 and then take the square root of 10, but then immediately square that number, taking the square root and squaring are exact opposite operations. So square rooting a number and then squaring that number cancel each other out. So the square root of 10 squared is just 10. Now let's look at the expression below this one. 10 raised to the 1/2 power squared. Well, I don't know what it means to raise 10 to the 1/2 power, but I do know that I can simplify this expression using my laws of exponents. 10 raised to the 1/2 squared can be simplified as 10 to the first. Because anytime we have an exponent raised to a power, which is the case here, we can multiply our exponents. So 10 to the 1/2 squared is the same thing as 10 raised to the 1/2 times 2 power, and 1/2 times 2 is 1. So this is the same thing as 10 to the first, which is 10. So let's look at what we just did here. In the first example, we had this expression, square root of 10. And when we squared square root of 10, we got 10. In the second example, we started with 10 to the 1/2. And when we squared 10 to the 1/2, we also got 10. So logically, that means that the square root of 10 must be equal to 10 raised to the 1/2 power. Because when we square both of these, we get 10. So square root of 10 and 10 raised to the 1/2 power, they are the same thing. As a matter of fact, anytime I have a number raised to the 1/2 power, I can rewrite that as the square root of that number. So what does it mean to raise a number to the 1/2 power? Well, it means to take the square root of that number. They are the same thing. Let's look at this example. Here we have the cube root of 10 cubed. Well, the cube root and the cubed cancel each other out. So that means that the cube root of 10 cubed is equal to 10. Now let's look at the example below that. We have 10 raised to the 1/3 power cubed. Here again, we can multiply our exponents to simplify, and 10 raised to the 1/3 times 3 is equal to 10. So in this example, we had the cube root of 10 cubed equals 10, and 10 raised to the 1/3 cubed equals 10. Logically, that would mean that the cube root of 10 has to be equal to 10 to the 1/3 power. Raising a number to the 1/3 power is the same thing as taking the cube root of that number. So anytime I see a number raised to the 1/3 power, I can just rewrite it as the cube root of that number. So let's look at these examples. Here we're asked to convert these expressions into radical form or into a radical, and then simplify them. The first example on the left is 9 raised to the 1/2 power. Well, I know that anytime I raise a number to the 1/2 power, that's the same thing as taking the square root of that number. So 9 to the 1/2 is the same thing as the square root of 9. And the square root of 9 is 3. So 9 raised to the 1/2 power is 3. Let's look at the second one. The second example is the opposite of 16/9 raised to the 1/2. Here the exponent of 1/2 is touching the parentheses, so the base is 16/9. So that means that when I convert this to radical form, that I'm going to take the square root of 16/9 and bring the minus sign down, because 16/9 is what's being raised to the 1/2 power, not minus 16/9. Well, the square root of 16/9 is 4/3, and so we bring down our minus, and we find that the square root is negative 4/3. Let's look at the third example. Negative 25 raised to the 1/2 power. Here, the base of this exponential expression is negative 25. So we have to take the square root of negative 25. Well, remember, anytime we try to take the square root of a negative number, the result is not a real number. So the square root of negative 25 is not a real number. And then let's look at the last example. Here we have negative 64 raised to the 1/3 power. Well, raising any number to the 1/3 power is the same thing as taking the cube root of that number. So here we take the cube root of negative 64. Well, what number times itself again, and times itself again gives us negative 64? That's negative 4. So the cube root of negative 64 is negative 4.